Hello everybody, my name is Hiba Hassan. I am a junior studying industrial engineering, and today I'm going to be covering a few questions in the course, i.e. 4850, which is just industrial engineering, economics, and economy. And these are just kind of basic principles in chapter 4 and 5, and the course kind of focuses on these basics. It just kind of builds up from here, so it's really important to get these down. But first, I'm going to be reading the problem and identifying what's given and what is not given. So, number 13. So it says, you arrange to borrow P equal to $19,000 for an automobile purchase. The loan will be repaid in N equals 48 equal monthly payments with end-of-month payments. Interest is compounded monthly at the rate of I equals 0.65% per month. What is the amount of the monthly payment? Use the formula. So here's our formula sheet given, but we have to decipher which formula we're going to be using. So first, I like to just lay out all my variables. So in this class, we are given p-value, which is usually equal to the present value. We're given future, which is equal to future. F is equal to future. We're given A, which is now it's annual. It doesn't really mean annual. It just kind of means the period that the problem is talking about. So in our case, it'd be monthly, but in most cases, it's called annual. So for ease of saying it, it's just A for annual. But it doesn't always mean annual. So when you see a problem that is either compounded monthly or monthly payments, or if it's quarterly, that's fine. That would just be your A. We've got G, which is a gradient. And again, these might not all be used, but we've got I, which is our interest. And then we've got N, which is usually like our life or period, like the life of the project or the life of the or size. Usually just put size, but in our case it's like the life of the purchaser, stuff like that. So let's see, what are we given? So we're given P is equal to 19,000. That is just straight up said, so that's really nice. We have 19,000 here. We have N is equal to 48 months, and since like everything is in months, monthly payments, interest is per month, it's compounded monthly, and it's asking for the amount of monthly payments, then we know that there's no converting needed to be done. So that's really nice. So our N is just 48. And let's see, what are we being asked? So one thing that I would really recommend doing is drawing a flow chart. And a cash flow chart just visualizes your cash input or output, and it just helps you know like where your money is going, and it usually is relative to the amount coming in and out. So for example, let me just do so usually, so we've got our present value, and if I'm borrowing 19,000, it is a downward purchase because it's negative, but in our case, cost is just going to be positive because we're spending it. So we've got that, and we know that this is going to go on for 48 months because it's asking what is the amount of the monthly payment, and we know that there are 48 months. So if it's a payment, I want to find our A. A means that these are equal costs. I'm going to be paying, or will be paid to me regardless, but for the size of our project, and in our case it's 48 months. So pretty simple. So our A is just in months, and if it's asking what is the monthly payment, then we know that now it's asking for A. So that is nice because we can get rid of the future. Get rid of gradient. And then interest was also given, and that was 0.65%. So I'm just going to write what I have. So this is our N. This is our P. A is what we're being asked. And then our interest is 0.65%. But whenever an equation is asking for interest, it's usually asking for it in a decimal. So you just divide that by 100. Oh, sorry. Divide that by 100 and you get 0.0065. So now what equation are we using? So you'll see on the left side, you see all of these notations, and it's given in like lines, and if you don't know what that means, it's usually like x given y. So this little line in the middle is just a notation for what's given and what's not. So what's on the right side of it is given. So you would say is x given y. So in our case, we know that we're given p. Yeah, we know that we're given p. So that helps us narrow it down. If we're given p, that means we could potentially use this one, and we could potentially use this one. So let's see. Oh, so here it is. Here's our problem because it's annual given, A given P, sorry. And that's exactly what it is. We're dealing with A, so we're most likely using this one. So let me just take this. Sorry, that took me a minute, but I got it. So now we can just plug and chug. So we have A and our P is 19,000. Then we've got our I, which is 0.0065. 1 plus 0.0065 to the power of n, which is 48. That is all over 1 plus 0.00, your interest, 0.0065 to the power of n, 48 minus 1. So when you get that, when you solve that out, you should get, we're talking about money, this is a cash flow, so 462.1. And now what does this give us? So this simply gives us, go back to the problem, what's the question asking? What is the amount of the monthly payment? So this is how much you'd pay each month for 48 months. So that is this problem. I hope it made sense, but it's just kind of basic. You just really need to know the notation and what you're given and what you're being asked. Next, I'm going to be doing an alternative problem, and these are very, very important in the real world because it's very realistic that in an engineering position, especially industrial engineering, you're going to be choosing between alternatives, and that's ultimately what's going to save the company sometimes millions of dollars. So, in this case, let's read it. It says there are two equipment alternatives for a manufacturing department. Models X and Y. Investment costs, annual costs, and useful lifetimes are given below. Salvage values are 0 for both alternatives. Your firm plans to operate the manufacturing department for a long time. Similar versions of each models will be available in the future with similar costs and characteristics. Which is the preferred alternative based on lower costs? Interest rate is equal to 20. Costs are 20%. Costs are positive, and for convenience, we want to minimize costs. Okay, so there's a lot of hints given. First, let me see what I'm given. So we know my interest rate is 20%. We talked about useful life, which is our N value, and those are 6 for each. We've got our X annual, our Y annual, and we've got our investment cost for X and Y. So you might ask yourself, what is investment cost? And investment cost is basically, it's just your p-value. Like, what are you spending? It's your present. When I go into a project, I'm spending this much on either the machine, the starting cost, and then annual self-explanatory is just our A value that we talked about, and then N is our useful life. So that's nice. And then if you wanted to, you could, to help visualize it before you start your cash flow, you could just find out the incremental costs, and this is just the difference between everything. So you would just subtract these. You would get 8K here for incremental cost. You would get 8K there, and then for your annual incremental cost, you would just subtract those, and you would get negative 2K. Now, it doesn't exactly prove useful in this problem, but in others it could potentially, and it's just an incremental cost, so it's nice to know. So what we're going to do right now is we are going to draw cash flows for both X and Y. So for X, we've got, so in this case it tells us costs are positive, so my arrows are going up. Usually it's relative to the amount, so the higher the amount, the longer the arrow, so just keep that consistent. So we are 32K. A little bit messy. So we've got 32K for our X, and then at year 1 we've got 4K. At year 2, 3, 4, 5, and 6 we've also got 4K. And so what is our 4K? 4K is our A value because it's consistent, equal payments throughout our useful life. N. So now let's draw out our Y, and then we can solve both because they're solved the same way, which is really nice. So for Y, same exact thing. Our useful life is the same. So we are initially paying 24,000, and then for 6 years I pay 6,000 for it. I got a bit generous with my lines. Okay, so we have our annual. Now, something to note that if you are given annual, first let's go and see like what we could potentially be using. So, actually let me explain this first. So, something to know is that this is actually a complex cash flow because it's two cash flows put into one. So something to know is that when you're given annual, your 0 right here there has to be no payment at 0, and in this case it is. So we're basically, so our actual annual cash flow would just be this stuff. It would just be this, but without the 32,000. So this is actually put into two cash flows. We've got our 32K, and then you've got your annual with 0. So you got your 1, 2, 3, all the way to 6 with equal payments. And this is a correct annual cash flow. This is just a present value. So it's pretty simple because we would just add it on. So to find what you need to find, your total value, you would just add those up. So with that knowledge, for our annual, we know that we're going to be using present given annual. Now, doing that is because we're given our annual, and the other problems given annual is up here, and we're not given future, so it wouldn't make sense to use that one. So let's just copy this. Let's hope I get this right. Here we go. So for our x, So for our x, we've got our 32,000 plus, that's when we use our p given a. So our annual was 4,000 with 1 plus our interest rate in decimal form is just 0.2. So it would be 1 plus 0.2 to the power of n, which is 6 minus 1. All over our interest, 0.2, 1 plus that interest to the power of 6. And then this yields $45,302. Okay, next we do the same thing for y. In this case, our present value is 24,000. And same thing, you just plug in check. 6,000. 1 plus same interest, 0.2, same useful life. So that's convenient. And then you got your interest, 1 plus that interest to the power of 6. So as you can tell, nothing is really changing other than the 4K and 6K, and then our present values as well. So it's pretty convenient, and this payment yields $43,953. And you know that these are so these look correct because they're very similar, and it makes sense because they're alternatives. So that makes sense. Now, what alternative do we choose? So here's what we're given. What alternative do we choose? So these are actually both net present costs, and because they're a cost, that means you're spending it. And this may be obvious to some, but you want to spend less. It's just like if you go to the store and get a candy bar, same candy bar, you find the same candy bar for $2, or you find a candy bar for $2 and then find the same candy bar for $1.75. You're just gonna get the one for $1.75. You just want to pay less. It's just a lower cost. So this goes the same for companies, and so because these are both costs, you would just choose the lower alternative. And so in this case, alternative Y is less than x. So y is the better alternative. I hope that explained it.